You're watching MyIPS on MyINDY-TV 23, a free educational service provided by Circle City Broadcasting of Indianapolis. Here's what's coming up this hour. Get more information, special announcements, and weekly program schedules online at wishtv.com. And be sure to follow us on Facebook. Here's what's coming up next.
All right, friends, it's your girl, Miss E. I'm here to do kindergarten, week 1, lesson 1. So friends, jump right in with me. So before we get started, I would like for you to take a second, go get a pencil, a piece of paper, and 10 items. So if you can see right here, I have some counting bears, I have some beans, I have some coins, pennies, and dime quarters. I have some Legos, and I also have some cars. So you can get 10 items of your choice and bring it back to the TV. I'm going to give you a few seconds to get it. All right, friends, welcome back. So in our home learning packet, week 1, day 1, it starts out with how many more to 5. And so friends, I'm going to use my whiteboard behind me to help me. What I would like for you to do is to grab your piece of paper, fold it in half, and on one side, I want you to do exactly what I do on the board. So friends, I am going to make a diagram. My diagram is going to have one big old circle. Then I'm going to make a line and another circle. I'm going to make another line and another circle. So friends, if you are unable to do this yourself, ask an adult or older sibling to help you out. So in my diagram, friends, I have this circle will be considered my whole. This one is a part, and this is a part. And so friends, this is called, does anyone know what this is called? If you said that this is a number bond, you are absolutely right, and you got it. So friends, in our number bond, a number bond helps us to add numbers together easily. So we have 2 parts and 1 whole. Say it with me. A number bond has 2 parts, and we're going to add those parts together and make 1 whole. So it may look like this. So this is our part, this is our part, and this will be our whole. All right, so friends, with number 1, it says 1 plus blank equals 5. So inside of your diagram that you made, we're going to put 5 of our items inside of our big circle, which is our whole. We have 5. When you have 5, give me thumbs up. All right, so we have 5. That's our whole. In order to figure out 1 plus what equals 5, I need to move one of my dots to a part because this is my part. Now I'm going to count the rest of the dots that I have in my whole. 1, 2, 3, 4. So I have 4. I'm going to move my 4 to my other part because they are a part of that whole. So 1 plus 4, because I counted 4, equals 5. All right, friends, I'm going to give you another problem. We are still going to be staying with equaling to 5. So I'm going to put my 5 back up there. Now, we have 5 equals blank plus 2. 5 equals blank plus 2. What should I do first, friends? Absolutely. If you said that I should take 2 of my dots and put it into my part, you are correct. Now what should I do? Count the whole? Okay. 1, 2, 3. So what do I move these? Awesome. I hear you talking. So I have 2 plus 3 equals 5. And friends, the way that we can check our answer is by counting our parts. 1, 2, 3, 4, 5. Awesome. Friends, you are on it. So for the rest of these, I want you to go through and figure out the answers to the rest of the problems. As we move on, I'm going to erase my board because we have another section. All right, so on the other side of your paper, we are gonna make a 10 frame. A 10 frame, We're gonna start with a rectangle. This marker isn't working. We're gonna start with a rectangle. And we're gonna split it in half. And we're gonna make 10 squares on the inside of our 10 frame. So there's 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. And so, friends, in a tens frame, it allows us to count up to 10 easily. So, for instance, if I had 2 dots in my 10 frame, how many more dots would I need to fill my empty spaces? Count for me. 1, 2, 3, 4, 5, 6, 7, 8. So I would need 8 more. And my number sentence would look like this. I had 2 plus 8 equals 10. Awesome job, friends. Okay, another one. If we are going to look at our home learning plan, where it is a 10 frame challenge. We have our 10 frame, and the first row is filled. So the question is, what is the largest number that we can now get from our tens frame? How many do we have now? Let's count them. 1, 2, 3, 4, 5. We have 5. And what will be the largest number to our tens frame? Let's just fill it up. 1, 2, 3, 4, and 5. So now my tens frame is filled. This will be the largest number that we will be able to create out of our tens frame. Friends, count that number and write that number on your paper. Then the question is, what is the smallest number we can create out of our tens frame? Let's just take them all off. How many dots do we have now? Write that number down as well. That is the smallest number that you all can create. Friends, I think that you all got it. So say it with me. I got it. Awesome. So now, friends, we are going to do a little counting. And I am going to mix my things up a little bit. I'm going to use my cars here. I'm going to line them up. All right, friends, count with me. I can count this way. I can count this way. I can also count up and down. So, friends, you choose the best way for you to count your items. So, but count with me as I point. 1, 2, 3, 4, 5, 6, 7, 8, 9. So I counted 9 cars. And I went in a zigzag line in order to count those cars. I also realized that I have 2 motorcycles and 2 Jeeps. And I also have a taxi cab. So friends, when we're counting different things, we can also tell the differences and the similarities that we have. So we have the same thing, which are cars, but they're different in many different ways. So on our home learning plan, we have a picture that we are going to count. Can anyone tell me what those items are? Awesome. If you said that it was an avocado, you are absolutely right, and Miss E loves avocados, especially when we make them into guacamole. Amazing. Okay, so friends, we are going to count our avocados, and you can count them with me. Here we go. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So friends, if you said 15, you are on it. Friends, how did you count? Did you go up and down? Or did you go left or right? Or did you do like Miss E and did you zigzag? Awesome. Well, either way that you counted, you got the right answer. But friends, what else did you notice about those avocados? Let me look. I noticed that some of the avocados still had a pit or a seed in it. Let me count those by themselves. 1, 2, 3, 4, 5, 6, 7. So I have 7 avocados that still have a pit. That means, let me count the ones that's without a pit. 1, 2, 3, 4, 5, 6, 7, 8. So I have 8 that is without a pit. Let's do a number sentence with that. So we have 7. No, that one doesn't work for me. We have 7 with a pit. We're going to use our plus sign. And we have 8 without a pit. And that equals 15. Awesome job, friends. Friends, you have been amazing today. You guys are so smart and you are rocking this math out the gate. So friends, today we got better at adding up to 5. We also looked at our tens frame and we added up to 10. And then we were able to count and look at differences inside of that picture. Friends, this has been a wonderful time with you, and this is Miss E signing out.
This is MyIPS on MyINDY-TV 23. Here's what's coming up next.
All right. Hey friends, it's your girl Miss E. I'm back again for kindergarten lesson, week 1, day 2. So friends, take a minute, get your home learning packet in front of you, along with a piece of paper, a pen or a pencil, and 10 items. 10 items that you can find around your house. Again, I have my counting bears, I have beans, I have pennies, I have quarters, Legos, and I have cars. So friends, take a minute, take a little second. I'm gonna wait for you to go get your items and come on right back here so we can get into this math. All right, friends, welcome back. So here we are again in math, lesson 2. And today we're gonna be working with 10. So we'll be adding numbers together, 2 numbers together to add to 110. So friends, today I think I am going to use my pennies. I'm going to move all the rest of this array. So just like we did with counting up to 5, we're going to do the same thing counting to 10. So I have my 10 pennies here. I'm going to keep them in this pile. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So with your 10, I want you to just put them right there in front of you. And so friends, we are going to take 3 of our pennies and put them to the other side. So now I have 3 plus this number. And then when we put them together, it's gonna equal 10. So I have my 3. Let's count this pile. 1, 2, 3, 4, 5, 6, 7. So 3 plus 7 equals 10. Absolutely, friends. You know what? You are on it already. Okay. Let's now take 5. 1, 2, 3, 4, 5. I have 5 over here, and then I have a number here. So I have 5 plus something equals 10. I'm going to give you a second. Count how many is in this pile. 5 plus, Let's count it. 1, 2, 3, 4, 5. If you said that you had 5 and 5, give me a thumbs up. I see your thumb. I see your thumb. You know what? You guys are on it. Say, I got this. Awesome. Friends, we're going to do one more of counting to 10. Put them all back together. And now we are going to take away 6. So count out your 6. And then what are you going to do with that 6? You're going to move it to the side. Awesome. And then what are you going to do? If you said you're going to count this pile, you rock. Count that pile. How many did you have? 4. You know what? Yes. So we have 6 plus 4 equals 10. Awesome, friends. Awesome. So proud of you all right now. So now, friends, we're going to move on to our caterpillar challenge. And so on your paper, you will see a caterpillar that looks similar to this. Maybe mine isn't as great as yours on your paper, but you have a caterpillar here. And friends, what we are going to do is we are going to fill in the missing numbers. We are gonna fill in the missing numbers. And Miss E came prepared. She also made you a number line just in case you get tricked up on what number comes after what number. So on our first one, we have a 2. And we have a 4. Oh, that ain't gonna stick up there. Let's just do it this way. So we have a 2 and we have a 4. And we need to figure out the numbers that come before 2, after 2, before 4, and after 4, and then those numbers that are after that as well. So looking here, we have 2. What number comes before 2? We also have our number line to help us out. So if you said that the number 1 comes before 2, you are on it. So even on our number line, we have 2, 1 comes first. Let's put our number 1 up. Awesome. I also have 1 missing here. A little different than what you have on your sheet. But we have a 1. What number comes before 1? We sometimes leave out this number, right? That number is 0. 0, we sometimes miss out on 0. We normally start counting at 1, but 0 comes before 1. So we have 0, 1, 2. I'm gonna go look at my number line because I don't know what comes after 2. Maybe one of my friends can help me figure out what comes after 2. 0, 1, 2, 3. Listen, friends, you don't have to yell at me. 3, yes. 3. So we have 3. So we have 0, 1, 2, 3, 4, 5. We have 5. And then what comes after 5? 5, 1, 2, 3, 4, 5, 6. Yes. Silly Miss E. She should know how to count by now. 6. Awesome. So now, friends, you will be able to try to fill in number 1. So we have our 2. Then we have a space, which is 3, 4, 5, 6. And then there's something that comes after 6, which is 0, 1, 2, 3, 4, 5, 6, 7. Yes, so friends, take a minute and fill in your first caterpillar. And I am going to take these down. And I'm gonna do another one. This time, I have 15. And what number is that, friends? Looks like a 1 and a 8. 81? 81? 18. Okay, I'm sorry. Miss E, can sometimes be forgetful. Okay, so we're going to fill in our numbers before 15, after 15, before 18, and after 18. So let's start with our 15. What number comes before 15? Maybe I should count on my number line. Can you all help me count on my number line? 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. That's the number I'm looking for. 15. What came before that? 14. Yes. Friends, you should have just told me it was 14. Had me going through all of that. So 14, 15, 16, awesome. 16, 17, awesome. Keep going, 17, 18, 19. You know what? You guys are so awesome at math. What comes after 19? The 20. Awesome job. Friends, pat yourself on the back and say, I got this. Awesome. So friends, next, after our caterpillar game challenge, there's a game that you can play with someone else, either an adult or an older sibling or just another sibling that you have around or a friend. And friends, it takes 2 players. And just like we put our coins in the middle, you're going to put these coins in the middle of you and whomever else is going to be playing with you. And you can choose, you're both going to rotate. One goes first. We'll say the person with the shortest hair goes first. So the person with the shortest hair can pull 1 or 2 of your items. You can't pull more than 2, but you have to pull 1. I know that's a little tricky, isn't it? So you can pull 1 or you can pull 2. And so you pull 1 or 2, then they pull 1 or 2. They pull 1, and you keep on going until the last item is taken. And whoever takes that last item, they win. So friends, let's see how many times you can go back and forth. And then start to think about, what did I do in order to win? So you have to pay attention to what it is that you're doing so that you can win on taking those items. So friends, today we got better at counting to 10. We took 2 numbers, we added them together, and we produced one whole 10. You guys rocked that out the park. And then we also did our caterpillar, where we put our numbers in order. We were able to count basically from 0 to 20. That is awesome. And then we ended with playing an awesome game to help us to do better at counting from 1 and 2. And then we won by getting the last coin. You know what, friends? You all are some awesome mathletes, and I enjoy spending this time with you. So friends, I will check you on another day. This is Miss E signing out.
What's going on?
I don't know.
Okay, try it now.
Yeah, that's IPS.
This is MyIPS on MyINDY-TV 23. Here's what's coming up next.
Okay, good morning. I'm Miss Gordon, and I will be teaching first grade math for week 2. We're going to be going over days 1, 2, 3, and 4. So let's start with our day 1, and you'll see on the front of day 1 that they're giving us 10 strips with some facts written next to them. So they're giving us these 10 strips, and we know that usually in first grade we see a lot of 10s in a 10s frame. So the 7 plus 7 is already done for you, and you can tell that they filled 7 on one side, so they had their 2 and 5, which gave them 7, then they got 2 and 5, which gave them 7, and they got 7 plus 7 is 14. The next problem that they had written down was 7 plus 8. So you're going to solve it a very similar way by putting 7 on this side, 8 on this side, and then counting how many all together. So go ahead and take a moment and just fill in 7 and 8, and let's see what our sum is. So after you fill that in, you probably saw that you got 2 and 5, which gave you your 7, and you got 3 and 5, which gave you your 8. But how much altogether? Well, I can see right here that I have 2 5s, so 5 plus 5 could be 10. So if I erase that, then I have 10. So I'll take these two together and I'll make 10. Then I look at my top 2 and 3. What does that give me? 5. And then we have 10 plus 5 is 15. So I want you to solve the rest of those 10 strips by doing the same thing and see if you can group your 5s together to make 10 and then add on. Okay, so let's move on to our next problem in day 1. You'll see that we have numbers that are written on a number line. And I'm looking at this number line and it seems like an open number line because it doesn't look like they gave me anything besides the 2, the greatest number and the least number. So I have to think they also left a box open that was in the middle. So I need to think about what could go in the middle of 50 and 90. I can tell that maybe since the numbers are 50 and 90 that they might be skip counting by tens. So if I had 50, I could think what's next? 60. Then I could think what's next? 70. Tell me what's next? 80. And then I have 90. So if I have 90 and 50 that I started with, what could be the number that came in the middle? I want you to take a moment. I want you to circle the number that you think, or maybe write the number that you think goes in the middle. And then you should have written 70. And the reason why 70 goes in the middle is because they are doing plus 10s. So they're saying 50 plus 10 is 60. So if they would have put a mark right here, that could have been my 60. Then they're saying plus 10. Okay, 70. So our pattern is increasing by 10s each time on the number line. Another 10, we could have put a slot for 80, and then we get 90. So the reason why we wrote 70 is because 70 is in between 50 and 90, and we identified the pattern was plus 10s. Okay, great job. So if you're looking at the next problem on day 1, I can see that they have shapes on strings. And I can also tell that this seems like it might be like a balance or some type of mobile. But I can tell that the sides seem as if they're equal. Why? Because if I remember a balance, it's a scale that shows weight. So if one side's heavier, then that means it's not equal. So I wrote down a few key terms such as value. We want to know the value of each shape. We want to know if it's equal sides, and we want to basically identify the value of the triangle. So they have given us the value of a circle. And what is the value of each of the circles? 4. So how many circles do we have? We have 1, 2, 3, 4. So that means that I have 4 plus 4 plus 4 plus 4, and I get my value of 16. So if I know that this side is 16, and I can tell that it's equal sides, I have to figure out how much are the triangles. So I'm going to take away the part that they've already given me because we do not know what the triangle is worth. We have to find that out. So if we know that a circle is 4, I'm going to take 16. I'm going to take my whole, which is 16, minus the part that they give me, which is 4. So think about 16 minus 4. I have my 10, 11, 12, 13, 14, 15, 16. I'm going to take away 4. 1, 2, 3, 4. How much is left? A 10 and 2, which gives me 12. So then, but I'm not done, right? Because I still have to identify how much one triangle is worth. But if I know that this side needs 12 more, how can I split 12 into 2 equal parts? Because I have a triangle that needs, I have one triangle over here that needs to know how much it is. I have one triangle there that I need to know how much they are. So if I take 12 and I split it in half equally, I would get 6 for each of the triangles. You would draw out your 12. And then you think, okay, they each get 5, and then they each get 1, which gives me 6 and 6. So I have 6 plus 6 is 12. So therefore, your triangle, each triangle is worth how much? 6. and 6 plus 6 equals 12 plus 4 gets you 16, which balanced the mobile and equation. Okay, good job, guys.
This is MyIPS on MyINDY-TV 23. Here's what's coming up next.
Okay, first graders, now let's go to day 2. And you'll see that we have a set of hearts that were given to us on day 2. And it's saying to count, it's labeled counting. And so we want to identify how many hearts there are. We obviously know that I could count by ones and identify how many hearts there are, but I want you to think back to the strategies that we used. Can you find groups of 3? Can you find groups of 5? Can you skip count by 2? Can you see a set together? Like right here, I see 3, 6, 7. I see a set of 7. Do you have a row? I see 3 rows of 4. So I want you to find a strategy and circle groups that go together, and identify the sum of the hearts. Okay, guys, so the next part of day 2 is you'll see on the page that there are sets of dominoes. And we use these all the time in first grade, right? We take part, whole, and we put them together. So the first one is done for you, and you can see that they had 7 plus 7, and they got 14. And you can see that they drew their line from 14 to match the word form to 14. So that's just an example of the first domino. But let's look at the second domino. I need to identify how many is in each part. So I have 3 plus 3, which gives me 6 plus 3, which gives me 6. And I know that 6 plus 6 is a doubles fact, and 6 plus 6 is 12. And so I need to match the word form to the number form. So I'm going to take my number form here in green, and I need to go find the word form for 12. 12. So I'm just going to look, if I don't have these memorized as sight words, I'm going to look for the blend at the beginning. So I'm going to look through, all right, and then I'm going to match it, 14, and then I'm going to, 12, and then I'm going to mark it out because I know I already used it, because there will not be a match for each of the number forms that you see on your page. So after you match one, mark it out, and then that will help you find the word forms for the numbers or for the sums that you find. Okay, good job.
This is MyIPS on MyINDY-TV 23. Here's what's coming up next.
Okay, first graders, let's find day 3 in our packets. At the top of day 3, we are going to see a story problem. And we are also going to see a fish tank that has some fish in it. So if you can't find your spot, look for the page that has the fish tank. Okay? All right, so we know that when we're reading a story problem that I really need to put myself into this story. I'm going to look for those keywords and pull out those important pieces of information that I read. So first I'm just going to read through, and I'm going to use my blue as my tracker. Tim has 12 fish. 7 are yellow, and the rest are red. Okay, so Miss Gordon's thinking, what do I already know? How many red fish does Tim have? Show your work. Okay, so I'm not done. I just can't read it one time, okay? We're going to read it back one more time, circling and underline our important information. So what do I know? I know that we're talking about fish. I see Tim's fish tank. I know that Tim says that he has 12 fish. Okay, and my character is Tim. So here we go. And then it says in the word form, 7 are yellow. So I do need to circle 7 because it is yellow. And I'm going to go ahead and match the number with the word form. And then I'm going to underline yellow because that's important. So 7 are yellow, and then what does he tell us? He tells us that the rest are red. Do we know how many are red? Does the words "the rest" tell me anything? No, but I do know that I could put a question mark because I don't know how many are red, but I do know that some are red. And then the question's asking, how many red fish are there? Okay, so what do we know? We know that Tim has 12 fish. So let's go ahead and just draw the 12 fish, and I'm going to just use circles, not fish, but you can draw fish, to identify how many. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Here's Tim's 12 fish. How many do we know are yellow? We know that 7 are yellow, so I'm going to go ahead and identify those 7 just by circling them yellow. So we have 1, 2, 3, 4, 5, 6, 7. So these 7 are yellow. Therefore, I already know how many left are red because it says the rest are red. It seems like this would be the rest. So how many are red? 5. How many does he have altogether? 12. So 7 plus 5 is 12. So we have 7 plus 5 equals 12. And I want you to write the number sentence to match our model. Thank you. Okay, guys, so the last part of day 3 that we're going to do is similar to last week's, and it's called make it equal. This is where they're telling us to use the digits 1 through 9 to make a true number sentence. And so if I have to make this an equal sentence, I have to attend to my equal sign. So I have an equal sign here, and I have an equal sign here. So I know that I need these parts to all equal the same. So I'm going to think, if I want to make the greatest sum, my greatest number is 9. So I'm going to use the number 9, and I'm going to put it in my first box. So I know that the sum that I'm looking for with these two parts is 9. So let's mark out 9. Now I want you to think, what two numbers can go together to give me 9? So if I look, well, the next greatest sum is 8, and I know that I could use 1 with 8. So let's go ahead and use 8 and 1, and that's going to give me 9. 8 plus 1, 9. Does 9 equal 9? Yes. Okay, we're not done though. We still have to go get a 3 add-in expression to equal 9. So let's think, what are two parts that I can put together to help me get to 9? If the next greatest part is 7, I can't use 7. I don't want to just use 7 though. Let's find two parts that equal 7. What are my facts that give me 7? Let's go ahead and just use 3 and 4. 3 and 4 give me 7. Okay, good. And then how much more do I need to get 9 with 7? Could I use 5, 6, or 7? No, that'd be too much. But I can still use 2. So I'm going to circle the 2, and I'm going to put the 2 there. So let's see if it works. 3 plus 4 is 7 plus 2 equals 9. So 9 equals 9 equals 9. And so we just balanced the number sentence to find the greatest sum, 9.
This is MyIPS on MyINDY-TV 23. Here's what's coming up next.
All right, scholars, so we are going to look at our day 4 part of our packet, and let's look at the first part where it says coloring. And it says to color half of each shape. So we can see that we have a circle, a square, and a triangle, and they are all partitioned into different fractions. And it's telling us to color half of each shape. I want you to just remember, what does it mean to color half? What does the term half mean? I'm just going to underline color half. I would like you to underline color half. And I'm going to remember that if I have half of something, that I have 2 equal parts, but I can also remember that the fraction half is 1 of 2 parts. So if I look at each of the shapes, the circle, the square, and then triangle, I want you to think, how could I color half of these shapes? For example, I'll do this circle for you, and I can tell that there are 4 parts, right? But we've talked about half of a circle. I think about a pizza. If I was to give my friend 2 pieces of the pizza, there's 1 piece. There's 2 pieces. How many pieces did my friend get? 2. But I can also say my friend got half of the pizza. So now I want you to look at the square and the triangle, and I want you to color half of those shapes. And you could even think about giving your friend half of the shape. Okay, good job. All right, first grade, you've worked so hard today, so thank you so much. And we're going to do the last problem on day 4. So let's look at the cubes that they have arranged in a pattern. And they're calling it a visual pattern. The first thing that I want to do when I'm just trying to identify a pattern is just kind of like look at it and see what I notice. So I want you to label how many cubes you see in each set. So I'm going to start by saying, okay, there's 3 here. Now go ahead and write how many are in your next set. There's 4 there. And how many are in that last third set? There's 5 there. And they're trying to say how many would be in the last set. And they want you to draw the last set. So what is the change in each series? 3 to 4 to 5. I can maybe see that they are getting greater by 1. I can see this one's added on, this one's added on. So now I want you to think, how could you draw the last one? Taking this model right here, where would you add the 6th cube? So I want you to draw that at the bottom of your paper on page 4. And then you work through it with your teacher this week. Okay, great job today, and I will see you guys next week.
This is MyIPS on MyINDY-TV 23. Here's what's coming up next.
Hi, first graders. If you are just joining us for the first time today, my name is Miss Lassiter. I was a teacher in North Carolina public schools, and as a teacher, my favorite subject to teach was math. Also, as a student, my favorite subject to study was math. Now, let's get ready for today's lesson. Today, we will be doing Grade 1, Module 4, Lesson 3. Ask an adult to help you grab these materials. You will need 40 small objects to help you count. You can use beans, blocks, cereal, crackers, paper clips, coins. Make sure an adult helps you find these objects. And when you have found these objects, save them because you will need them for other lessons. Today you will also need a whiteboard and dry erase marker. If you do not have a whiteboard and dry erase marker, that's okay. You can use a pencil and paper. But also, if you don't have a pencil and paper, you can follow along with me. Next, your student workbook. In your student workbook, you can find the place value chart that we will use today and your problem set. If you do not have your student workbook, that's okay. But today, let's start with our magic counting sticks. Show me your magic counting sticks. Yeah, these are your magic counting sticks. Go ahead and wiggle, wiggle, wiggle. How many magic counting sticks do you have? Did you say 10? Show me your magic counting sticks as 110. Yes, this is our magic counting sticks as 110. How many 10s do we have showing right now? 110. How many 1s do we have inside of our 110? Think about it. Yes, we have 10 1s inside of our 110. Complete this statement. 110 is the same as 10 ones. Complete this statement. 10 ones is the same as 110. Now, using your magic counting sticks, I want you to show me the number 34. You're probably thinking, I can't show 34 with my magic counting sticks because I do not have enough. I was thinking the same thing. So I grabbed some of my friends. How many tens and ones make up the number 34? Did you say 3 tens and 4 ones? How many ones are in the number 34? At first I thought 4 ones also. But if I only had to use ones to make up the whole number 34, how many ones would that be? Yeah, looking at my friend's magic counting sticks, I can see there are more than 4 ones. How can we count the magic counting sticks that we see to make sure that it is still 34? Did you say that we can count them? How can we count them? I was thinking that we can count them by tens also. Count them with me. 10 ones, 20 ones, 30 ones, 31 ones, 32 ones, 33 ones, 34 ones. How many ones do you see? Yes, 34 ones. How many ones is the same as 3 tens and 4 ones? Did you say 34 ones? Absolutely. There are 34 ones and 3 tens and 4 ones. Now we are going to show some more numbers. You can use your magic counting sticks if you have enough friends. If not, you can use your 40 objects that you gathered with an adult at the beginning of the lesson. At this time, pause the video to show 27 ones. Does your 27 ones look like my 27 ones? How can we show 27 ones as tens and ones? How can we show 27 ones as tens and ones? Do your objects look like my objects? 27 ones is the same as 2 tens and 7 ones. 2 tens and 7 ones is the same as how many ones? Yes, 27 ones. Pause the video and show me 37 ones. Once you have built your 37 ones, come back and press play. Do your objects look like my objects? How can we show 37 ones as tens and ones? Do your objects look like my objects? Yes, 37 ones is the same as 3 tens and 7 ones. 3 tens and 7 ones is the same as how many ones? 37 ones. Show me 10 ones. Do your 10 ones look like my 10 ones? What can we do to show our 10 ones as tens and ones? Do your objects look like mine? 10 ones is the same as 1 10. 1 10 is the same as, 10 ones. Show me 40 ones. Show me 40 ones. How many tens is the same as 40 ones? Do you have 4 tens also? Complete the statement. 4 tens is the same as, yep, 41s. Complete the statement. 41s is the same as 4 tens. Pause the video to show me the number 26. Do your objects look like my objects? How many tens and ones do we have in the number 26? Did you say 2 tens and 6 ones? How can I show this number on my place value chart? Yes, I can write 2 tens and 6 ones. How many ones are in 2 tens? Did you say 21s? How many extra ones do we have? How many ones do we have all together? Can I show 26 ones on my place value chart? Absolutely. Looking at my place value chart, I can see that 2 tens and 6 ones is the same as 26 ones. Pause the video to show me 36. Do your objects look like my objects? How many tens and ones are in the number 36? Did you say 3 tens and 6 ones? How can I show that on my place value chart? Did you say 3 tens and 6 ones? Let's write it together. You write 3 tens and 6 ones on your place value chart. How many ones are in 3 tens? Did you say 30 ones? How many extra ones do we have? How many ones do we have in 36 all together? Can we show that on our place value chart? Yes, write it on your place value chart. 36 ones. Pause the video to show the number 30. Do your objects look like my objects? How many tens and ones are in the number 30? Yes, 3 tens. How can we show that on our place value chart? We have 3 tens and 0 ones. How many ones are in 3 tens? Did you say 30 ones? Do we have any extra ones? Nope. How can we show that on our place value chart? We can write 30 ones. Complete the statement. 30 ones is the same as 3 tens. Complete the statement. 3 tens is the same as 30 ones. At this time, let's have a look at our problem set that you're going to complete on your own in just a little bit. On your first page, you're going to count as many tens as you can and then complete each statement. Say the numbers and the sentence. So I'm going to look at number 1. I see that there is 1 10 and 1, 2 ones. So now let's complete the statement. 1 10, 2 ones is the same as 12 ones.
You're watching MyIPS on MyINDY-TV 23, a free educational service provided by Circle City Broadcasting of Indianapolis. Here's what's coming up this hour. Get more information, special announcements, and weekly program schedules online at wishtv.com. And be sure to follow us on Facebook. Here's what's coming up next.
Hi, I'm Miss Price, and I am teaching second grade, week 2, day 1. The question is battling bugs. Susie Spider and Freddie Fly are playing a game of battling bugs. Fill in the sentence beside the strips to show the difference between their scores in each problem below. Write or complete a subtraction equation to match. So we know that we're working on subtraction, and subtraction means we are looking for the difference. So let's do mirror words and gestures. You will repeat after me. Mirror words and gestures. Minus means take away. Equal means how many left. Break your mirror. Okay, so the first problem has 6. So we have 6 right here. And then the second one has 3. And we're trying to figure out the difference between 6 and 3. So if we look here, what is the difference from this top row to the second row? So 6 minus 3 equals 3. 3 is the difference there. And then you just do that for the next problems that are on this page. And then at the very bottom, it says add up each bug's points to find out who won the game. So now it's telling us to add. So I have another mirror words and gestures. Mirror words and gestures. Plus means add more. Equal means all together. Break your mirror. So for this one specifically, we're going to try to make 10 in order to make adding easier for us. So I'm going to go with Freddie Fly. Freddie Fly has 3 points, 4 points, 7 points, 6, and then 10 more points, and we're trying to figure out how many he has all together. So I am going to make 10. 7 plus 3 equals 10, and then 4 plus 6 equals 10, and then I'll just bring this 10 down. So that should be really easy to solve now because you can skip count by 10. And there are a few questions underneath. It says which bug won, by how many points, show your work. On the very next page, we're continuing for day 1. It says time twister. Using the digits 0 to 9 at most 1 time each, create 3 different times on the clocks where the span of the times are between 12 noon and 7 p.m. How can you make the difference between the times the greatest or the closest times together? So I am going to try to draw some clocks. So I'll label it quickly. And we can only use digits between 0 and 9, and we can only use those digits one time. So I'm just going to go with the shorthand is the hour hand, so it'll be 1 o'clock, and then the long hand is the minute hand, and we skip count by 5s for that, so it'll be 5:10. So this first clock says that it is 1:10. And I cannot use 1 or 2 again. So the next time I'm going to go to 3 o'clock and just go right next to it again. I don't want to give you the answer for all of them. So remember, when you're going for minutes, you skip count by 5. So you skip count by 5, figure out what this minute is and add that there. And then the final clock, you can just go ahead and do that by yourself. You can't use 1, 2, 3, or 4 now. And you want to see if your time can go all the way up to 7 p.m. without reusing any of the numbers that we've used so far. And the final question for day 1 is, what is the value of the trapezoid? So if you're looking at your paper, it's balanced, which means it's even, and on one side there are 3 hearts. And the 3 hearts each equal 2. So it'll be 2, 4, 6 is the total. And then on the other side, there is 1 trapezoid and 1 heart. So we already know that that heart represents 2, but we need to figure out what does the trapezoid represent in order for it to be balanced. So both sides equal the same thing because they're balanced, but we need to figure out what the trapezoid represents. All right, kids, that was it for day 1. Thank you for listening in. I'll see you next time.
This is MyIPS on MyINDY-TV 23. Here's what's coming up next.
Hi, it's Miss Price again. I am teaching grade 2, week 2, day 2. So in our packet, it says counting. How many eggs do you see? And I tried to create the egg card in here for you. And it says how many are missing? How do you count them? So it's 3 different questions. How many eggs do you see? And I would probably count them by going across the rows. Remember, rows go across, or you can count them by their columns, which is up and down, whichever is easier for you. And now that I'm looking at it, counting by columns would probably be easier because how many are in each column? 1, 2, 3, 4, 5. There are 5 in each column, so then you can skip count by 5, count all of them, get your total because it asks how many eggs do you see, but then notice here that these circles mean that some are missing. So once you get the total, you can take that amount away and then you'll see how many are missing as well. And then you can tell us, how did you count them? Did you count them by skip counting? Did you count them by counting 1 by 1? Or did you count this side first and then add it to this side? Whatever it is that you did to count them, just let us know on your packet. We're going to go on to the next page. It says 2-digit addition. When Pencil Puppy does 2-digit addition, she adds the 10s first. Next, she adds the 1s. Then she adds the 2 numbers to get the answer. Try her strategy. So I'm going to walk through her example with you. So our 10s and 1s, I am abbreviating. And she had 37 plus 27. So if we're adding our 10s first, we want to make sure that we represent, there are 3 10s here, so that's 30. And then there are 2 10s here, that's 20. and then all you have to do is add the 10s, you get 50. And now we're going to just the ones, so just this column. 7 plus 7 equals 14, and now we'll add these two numbers together. And you should get 64. And you have 5 more of those to do by yourself. And you can also, if you want to, you could have done this as 5, 10, and then like that, so it could have been even easier. But however it's easiest for you to work out is how we want you to do it. Just make sure you show all of your work there. Okay, so the last problem on this page says stacking up. So arrange these number blocks into 3 equal stacks so that the sum of the numbers displayed in each stack must equal to any other stack. So here are my stacks. There are 9 total blocks, and then there are 9 total digits that we can use, 9 different numbers. And we just want to write 1 digit in each box, and they have to equal. Like whatever this adds up to equal, this needs to add up to equal the same number. So I'm just going to play with some numbers. So 1 plus 2 is 3, 3 more is 6. What numbers can I use here that also equals 6? And I can't use any of these numbers. Nope, already used 3. Learning as we go. So what other numbers could I use that'll equal 6? None. So I need to start over again. But that's okay. You all can keep going through this until you figure it out. I would love to see what you all figure out. So if you have my contact, you should send me a picture of that. Thank you for tuning in today too. I look forward to seeing you on day 3 shortly.
This is MyIPS on MyINDY-TV 23. Here's what's coming up next.
Hi, it's Miss Price again. I'm back, grade 2, week 2, day 3. So I'm going to go ahead and read the story problem for you. It says, the kids in Ms. Nelson's class did a survey of all the 2nd grade classes to find out about kids' favorite pets. Use their chart to help answer the questions below. So the chart is on your paper, but I only represented the work for question A. It says, how many more kids like fish than birds the best? Show your work. So I represented fish here. How many fish are there? It's 17 total fish, and then it says how many birds how many students like birds best? So this represents how many birds there are. So we're trying to see how many more kids like fish than birds. So here you're finding the difference. And then problem B says how many more kids like dogs than cats the best? Show your work. So you can do the same setup, represent how many dogs and how many cats, and then figure out what the difference is. And we're going to go ahead and move on to the next problem. It says subtraction with regrouping. Using the digits 1 to 9 at most 1 time each, fill in the boxes to make the difference equal to 39. Use base 10 drawings to help. So here it's already set up for you. We know that there are 2 digits and it's different, so we know that we're subtracting, and it gave us the answer. But we need to figure out what the whole number is and what we're subtracting from it to get this difference. So again, this is another situation where you'll have to play around with numbers to figure out how you'll get this answer. And because we are subtracting, we're going to have to regroup. So that's why it said to use your place value, so you can use the place value chart to help you. You can draw some examples and then work through it using place value disc or just the little dot as you're drawing. I'll leave you to play with those numbers. And then our final problem on this page says, which one doesn't belong? Choose an object in this picture that you don't think belongs with the rest. Explain why. Can you pick another object and give a different reason? So there are 4 objects. There's a heart, a star, an arrow, and then another polygon that has lots of sides. So I am going to say the one that you all are probably going to choose is the polygon, and probably because it's not shaded in like the rest of the shapes. So now I've given you one example and one reason. I want you to think through all the different options that you have, like what other shapes are different than the others and why. And thank you again for tuning in. This was the end of day 3. I'll look forward to seeing you again soon.
This is MyIPS on MyINDY-TV 23. Here's what's coming up next.
It's Miss Price. I'm back for day 4. This is grade 2, week 2, day 4. So we are going to start with a visual pattern. It says below is a pattern of squares in stages 1 through 3. Draw what you think stage 4 might look like. Label how many squares are in each stage. So I've tried to recreate it here for you. And let's take a look for a second. What do we notice is the same in each stage? What I notice is that the circles on the outside, or on your packet, they're squares, are the same in each stage. And how many squares on your paper are there on the outside of each stage? 4, right? There are 4. So now, what's changing? The inside. So here we only have 1 on the inside, and there are 4 on the outside. So how many total do you have there? And then here, how many are on the inside? There are 4, and there's still 4 on the outside. And here, how many are on the inside? 3, 6, 9 on the inside, and there are still 4 on the outside. And then they're telling you to draw stage 4. So you can figure out how that will look and draw it on your paper. We are going to go on to the next problem. It says noticing. On a piece of paper, make 2 columns. In one column, list the things that are the same in this picture, and in the other column, list the things that are different. So I am going to create a T-chart for you. Column 1 will be what's the same. Column 2 will be what's different. So what I noticed that's the same is that it's a rec and rec in each one. And what's different is the different colors. So some are red, some are white. And I want you to take a closer look, and see what else is the same or different. And we're going to go to the final problem, which is our story problem. Jen had some flowers. Her friend gave her 9 more. Now she has 14 flowers. How many flowers did Jen have to start with? Show your work. So we know how many she has in all. We know how many were given to her, but we don't know how many she had to start with. How do we figure that out? So how many did Jen have to start with if she received 9 more, and that gave her a total of 14? And it says show your work, so you can draw pictures or you can just rearrange the numbers and work it out. I don't want to show you anything that'll give you the full answer, so I just want you to know that this is what you're going to fill in and show your work to tell us how you got that. Thank you so much for tuning in. I hope that you all stay safe.
This is MyIPS on MyINDY-TV 23. Here's what's coming up next.
Hi everyone, it's Ms. Price again. I'm here for day 5 of week 2, grade 2 math. I am going to read a word problem for you, and I need you to listen very carefully so you know what you need to pull out so that we can solve the problem together. There were 15 cookies on the plate. It's 15 cookies on the plate. The dog ate some of them. Now there are only 7 cookies on the plate. How many did the dog eat? Show your work. So remember, we're also listening for keywords to let us know which operation to use. So we started out with 15, that's our whole number. And it says the dog ate 7. So now we're trying to figure out, no, sorry, the dog did not eat 7. We're trying to figure out how many the dog ate, but there are 7 left on the plate. So if I took some of these away, I'm not gonna do it because that'll give you the answer, but you figure out how many the dog ate if there are only 7 left. So that's your equation there, and you need to show your work. And then we're sorting numbers. Read the numbers in the box, then write them in order on the lines from least to greatest. So least is the smallest number, and greatest is the larger number. And I need you to make sure you pay very close attention to these numbers because you need to look at the place value to make sure that there's one that only has 2 digits. So I gave you a hint there, that's probably the least. But then there's some of them that have the same digit in the same place. So you need to figure out by looking at the next place what the value is to truly put them in the correct order. And then the final problem says add, subtract, and compare. Fill in the missing numbers on the addition table. Some of the numbers have already been filled in for you. So on the table, there are some numbers across the top in that row, and then there's some numbers down the side in that column. And you're basically just adding the numbers across. You can go down the column, then go over to the next number and go down the column until you get all of those boxes filled in. All right, so that's the end of day 5. Thank you so much. Make sure you stay safe and don't forget to floss. Bye.
This is MyIPS on MyINDY-TV 23. Here's what's coming up next.
Hi and welcome. If this is your first time joining me, my name is Mr. Waldorf. I was a teacher in Arkansas for 19 years, and now I am with Great Minds in North Carolina, supporting teachers and students with Eureka Math. I love teaching math, and I'm so glad you're here with me for Grade 2, Module 6, Lesson 3. Today we are going to continue to count equal groups of objects and use addition to find the total number of them. For today's lesson, you're going to need the following materials: a whiteboard and marker, and if you do not have a whiteboard and marker, that's okay. You can just use paper and pencil. You also need your problem set and a pencil. If you cannot get a problem set printed, that's okay. You can still just watch along with me and still learn. Okay, let's look at our first problem. First of all, let's look at what we have with our counters here. How many groups do we have? We have 4 groups. 1, 2, 3, 4. How many do we have in each group? 1, 2, 3, 4. There are 4 counters in each group. In our last lesson, we talked about how we can use repeated addition to find the total number of objects with equal groups. Looking at these equal groups, what repeated addition problem could we use to find out how many total counters we have? Well, we have 4 groups of 4, so I could add 4 plus 4 plus 4 plus 4. Now that can be kind of a tricky addition sentence to try and solve because that's a lot of 4s in a row. And if I don't know how to count by 4s quickly, I might need to create an easier problem. How could I create an easier problem for 4 groups of 4? Well, one thing I can do is I can group pairs of numbers. Here I see I have a 4 and a 4. What do 4 and 4 make? We can see it with our counters. If I put this 4 and this 4 together, now instead of 2 groups of 4, I have 1 group of 8. And again, what if I add this 4 and 4 together? Again, if I look at my counters, if I put those 2 groups of 4 together, I now have 1 group of 8. Now what do I need to do with these 2 groups of 8? Well, I see that I was adding, so I need to continue to add these 2 groups of 8. And if I know my doubles well, I can do 8 plus 8 a lot easier than I can do 4 plus 4 plus 4 plus 4. 8 plus 8 is what? 16. If 8 plus 8 is 16, what is 4 plus 4 plus 4 plus 4? It's also 16. Okay, let's try another one. Okay, you're going to get to join me in making groups now. But we're going to draw them instead of making it with physical objects. What I want you to do is make a group of 5. And in order to do this, let's first just create our 5 small circles. That is 1 group of 5. Now I want us to make 4 of these groups. If you need to put a circle around your group to help you see it as a group, you can do that. Let's go ahead and make 5 more. There's my second group. Another group of 5. And then 1 more group of 5. Okay, let's go through our process of creating a repeated addition problem for this. How many groups of 5 do I have? I have 4 groups of 5. So what is our repeated addition problem for this group of objects? 4 groups of 5 would be 5 plus 5 plus 5 plus 5. Now again, that's a long string of numbers to have to add together, but I can create an easier problem. So what can we do to create an easier problem in this one? Let's look at pairs of numbers again like we did with the groups of 4. Looking at this one, we have 2 groups of 5 here. And again, I can look at these 2 groups of 5. What is 2 groups of 5? 2 groups of 5 together is 10. I have another 2 groups of 5. That would be another 10. Now what do I need to do with these 2 10s? We need to add them together. And I forgot to show you that here's our other 10. What is 10 plus 10? 20. If 10 plus 10 is 20, what is 5 plus 5 plus 5 plus 5? It is also 20. Now let's look at this in our group language. We can say that 4 groups of 5 equals or is the same as what? We made 2 groups of 10. 4 groups of 5, 1, 2, 3, 4 groups of 5 is the same as 2 groups of 10. We can also see that with our addition problems.
This is MyIPS on MyINDY-TV 23. Here's what's coming up next.
Hi third graders, and welcome to Grade 3, Module 5, Lesson 3. I'm Miss Roos, and I taught in Pasco County Schools in Florida for 9 years. Math was always my favorite subject, and so now I get to work for Great Minds. And while we're out of school, Great Minds is doing everything we can to make sure that we're supporting building knowledge on the go. Here are the materials that you'll need for our lesson today. First, you'll need some paper, a pencil, and your Lesson 3 problem set. It looks like this. If you can't print it out, don't worry. When we get to the problem set time, I'll put the problems on the screen and you can copy your answers onto a blank piece of paper. Here, I have a rectangle. I want to fold this rectangle into 4 equal parts. Let me darken the lines so you can see my 4 equal parts. What do you notice? Maybe you were thinking, Miss Roos, those aren't equal parts because this piece and this piece are bigger than these 2 pieces. So that doesn't mean that they're equal. Let me try again. Here's the rectangle. I'm going to try again to fold it into 4 equal parts. Those look much more equal. Okay, so now that we have 4 equal parts, what's the fractional unit for 4 equal parts? Think it first. Say it. Fourths. So if the fractional unit is fourths, what is each part called? Think it first. Say it. 1/4 or 1/4. I'm going to shade 3 copies of 1/4. What fraction is shaded? Think it first. Say it. 3/4. Let's count them. 1/4. 2/4, 3/4. Okay, I have a circle now. I want to fold this circle into 2 equal parts. What do you notice? I didn't do a very good job of making them equal. Maybe I should try that one again. Here's a circle. Let me try again to fold it into 2 equal parts. I think those parts look much more equal. So now that I have 2 equal parts, what fractional unit do I have? Think it first. Say it. Halves. If these are halves, what is each part called? Think it first. Say it. 1/2. I'm going to shade one part of our circle. What fraction have I shaded? Think it first. Say it. 1/2. I've shaded 1/2 of the circle. Let's count our halves. 1/2 is shaded and 1/2 is not. Great job. So now we're going to analyze some shapes together. Here's how this activity is going to work. I'm going to show a shape on the screen, and then we're going to talk through some questions together. Ready? Here's our first shape. How many equal parts do you see? 3 equal parts. What is the fractional unit for a shape with 3 equal parts? Think it. Go ahead and say it. Thirds. If this shape is partitioned into thirds, what is one of the pieces called? Think about it. Go ahead and say it. 1/3. So now I see that there are 2 pieces shaded. What fraction is shaded of this shape? 2/3. There are 2 of the 3 equal pieces that are shaded. Let's try another one. Here's our next shape. How many equal pieces is this shape partitioned into? 4 equal pieces. What is the fractional unit for 4 equal pieces? Think it. Go ahead and say it. 4ths. What is each part called? 1/4. So let's look at this shape. What fraction is shaded? Think it. Say it. 1/4. Okay, here's another shape. How many pieces is this shape partitioned into? 8. I see 4 pieces on top and 4 pieces on the bottom. What is the fractional unit for 8 equal pieces? Think it. Go ahead and say it. 1/8. What is one piece called? 1/8. In this shape, what is the fraction of the shaded pieces? Think it. Say it. 5/8. Okay, it's our last shape. Here we go. How many equal pieces is this shape partitioned into? 3. What is the fractional unit for 3 equal pieces? Think it. Say it. 1/3. What is one piece called? 1/3. Take a look at the shape. What is the fraction of the shaded pieces? 2/3. For this next activity, you're going to need a blank piece of paper. Go ahead and pause the video now so you can get that paper, and then press play when you're ready to begin our next activity. For this activity, I'm going to ask you to draw a shape, partition it into equal pieces, and then shade a given fraction. Make sure not to draw your shapes too big because we have a couple of examples to go through. Ready? The first shape I would like for you to draw is a rectangle. Partition it into thirds and then shade 1/3 of the rectangle. Here are some examples of what your rectangle might look like. Notice that there are more than one way to show thirds on the rectangle. I also want you to notice that in this first picture, I shaded in the middle. In the second picture, I shaded on the bottom. It doesn't matter which piece you shade as long as you are showing 1/3 of a rectangle. Let's try another one. This time, I want you to show me 2/6 of a square. Press pause if you need more time. Here are some examples of what your 2/6 of a square might look like. Notice how my sixths look a little different. In the first example, I made 6 differently than I made them in the other two. But no matter which way they are all examples of sixths because they each show 6 equal pieces. Again, I shaded any 2 I wanted because that represents 2/6 of the square. Let's try one more. This time I want you to see if you can show me 3/4 of a line. This one was a little tricky for me, so I want to talk you through my thinking. First, I drew a straight line. Then, I found the halfway and I drew a little dot. Next, I thought back to those folding activities that we've done, where I fold in half, and then if I fold again, when I opened my fraction strip up, I had 4 equal pieces. So I tried to think about what that would look like on a line. So instead of folding it, because I couldn't because it's a drawing, I decided to put a point here and here. Now I can see on my line 1/4, 2/4, and 3/4. Great job with our lesson today. Let's move on to our problem set. Here are the pages to the problem set. If you don't have them printed out, let's go ahead and check our answers. Check your answers to the problem set with the problem set answers on the screen. Push pause so that you can make sure that you check your work thoroughly. Let's go ahead and talk about a couple of these problems. First, let's look at number 4. I want you to answer out loud as if you were talking to a classmate. How could we explain to this student why they've not shown halves despite drawing a line to show 2 parts? You may have noticed that where this student drew the line, it does make 2 parts. They are not 2 equal parts. The shape kind of goes out at the bottom. So the top part is not the same size as the bottom part. On your board or paper, draw how they should have partitioned this shape. We could tell the student that this is showing halves because the parts are 2 equal parts. Let's talk about one more question. Number 5. Did this student show 6ths on their circle? No, this student did not show 6ths on their circle. Again, they drew 6 pieces, but those pieces are not equal. On your paper, draw how you would represent 6ths on the circle. Push pause if you need more time to draw your circle into 6ths. Here is what the circle should look like. Notice how all 6 of the pieces are the same size. That's it for today. I'm Mrs. Roos. Don't forget to tell your teacher that you're hard at work. Bye.
Well, hello. I hope you enjoyed your lesson with Miss Roos. I'm Mrs. Chin, and today I'm going to be walking you through our fluency activity. Hint, all of our factors are going to include 6. So feel free to skip count by 6, 12, 18, 24, all the way up as needed. Are you ready? What is the product of 6 times 1. 6 times 1. Think about 6 groups of 1 or 1 group of 6. 6 times 1 is 6. Excellent. Let's try another one. What about 2 times 6? 2 times 6 is 12. Let's do another one. 6 times 2. So maybe you can draw an array with 6 groups of 2. Maybe you can skip count by 2 6 times. Maybe you could skip count by 6 2 times. So 6 times 2 is 12. Excellent. Let's keep going. What about 3 times 6? 3 times 6. And again, maybe we can draw an array with 3 rows of 6. We could skip count by 3 6 times. We could skip count by 6 3 times. So let's try that. I'm going to skip count by 6 3 times. That looks like 6, 12, 18. So 3 times 6 is 18. Let's pick up the pace a little bit faster. What is 6 times 3? 6 times 3 is 18. Let's do 2 more. I'm going to try to make it more challenging. 5 times 6. 5 times 6. Do your best. 5 times 6 is 30. And maybe you either skip counted by 5 6 times or skip counted by 6 5 times. Maybe you drew an equal group. Excellent job. Let's do one more. 6 times 5. 6 times 5 is 30. Nice job. Now I want you to pretend you have a classmate next to you, and I want you to turn and talk to that classmate. What patterns do you see happening between our multiplication sentences? Maybe some of us noticed that each multiplication sentence has 6 as a factor. What other patterns do we see? Maybe some of us noticed that our factors are getting larger as we progress through our multiplication sentences. We had 6 times 1, then we had 2 times 6, 6 times 2. Did we see any patterns between a couple math sentences, a couple multiplication sentences? Some of us may have noticed that we have that commutative property. So when we change the order of our factors, our product stays the same. Same with here. When we change the order of our factors, our products stay the same. Excellent. Thank you so much for enjoying our fluency activity with me today. I'm going to pass you off now to Mr. Moses, who's going to walk us through our application problem. I hope to see you again tomorrow.
Hey, third graders, it's Mr. Moses. I'm with you again today to work on your application problem from Module 5, Lesson 3. The materials we're going to need today are over to my left. We're going to need the Lesson 3 application problem, as you see in the screenshot, or a piece of blank paper, either will do, and a pencil. Go ahead and pause the video, go get those materials, and then start the video again when you're ready to move forward with our application problem. As we always will do whenever we're working on a word problem, we're going to use this read, draw, write process, which is we read the problem, we draw and label a model as we reread the problem, we write an equation, and we write a word sentence or a statement to answer the question. Today's application problem is to the left of me. Let's read it together. Marcos has a 1-liter jar of milk to share with his mother, father, and sister. Draw a picture to show how Marcos must share the milk so that everyone gets the same amount. What fraction of the milk does each person get? So this problem really reminds me of all of that work you've been doing in lessons 1, 2, and 3 so far with Mrs. Roos. We're going to continue that work in today's application problem. And we're going to go back and now we're going to reread this problem and draw and label a model as we reread. All right, so on your application problem or your blank sheet of paper, let's go ahead and start digging into this. I'm going to start rereading again and we'll pause to draw and label a model. Marcos has a 1-liter jar of milk. Let's just go ahead and stop there and let's represent that chunk of text. Marcos has a 1-liter jar of milk. Pause the video, draw that real quick, and then start the video up again and we'll pick up from there. All right, so for this we're just going to be drawing a tape diagram. Some of you might have drawn it horizontally, as we've been doing most of the year through most of our modules. But some of you may have said, well, it's a jar of milk, and jars of milk are actually vertical or taller than they are wide, so it might make sense to draw it this way for this problem. Either way works. It's a representation of the context of the problem. No matter how I drew it, what does this rectangle represent from the problem? Because we always want to label to make sure we fully understand what's happening. Go ahead and label your tape diagram, whether you drew it like this or like this. The label we should include is that this is a 1-liter jar of milk. And this also is a 1-liter jar of milk. So the rectangle itself is representing the milk. Whenever we're working, if you ever need to pause your video to fix something or to catch up, pause that video, catch up with where I'm at, and then restart that video and you can keep rolling with me. All right, so let's pick up where we stopped reading, which was right here. To share with his mother, father, and sister. So I'm trying to think right now. I know that he needs to give some to his mother, to his father, and to his sister, but Marcos is there too. So I'm going to keep reading to see if it gives me any indication of whether Marcos is getting some of the milk as well, or if he's just giving it to mother, father, and sister. Let's read. Draw a picture to show how Marcos must share the milk so that everyone gets the same amount. The idea that it says everyone makes me feel like I must need to include Marcos. So now what I need to think about is, how am I going to partition my liter of milk? Whether I drew it horizontally like this or vertically like this, I need to be thinking, how am I going to partition that? So think in your mind, how do you need to partition that representation? So some of you may be thinking into 3 equal parts because of mother, father, and sister, but we cannot forget about Marcos. Marcos is a 4th person. So what I want you to do now is pause your video and partition your model, whether it was a horizontal model or a vertical model, into 4 equal parts. Pause your video and do that partitioning, and then start it up again once you've done that partitioning. All right, I'm going to show you real quick how I partition things into 4ths in a way that helps me to get it more accurate. If I just start over here and start partitioning, sometimes the way that I start makes it difficult for me to keep all of my pieces equal, which when we're partitioning something into fractional parts, it's really important that they're equal. So the easiest thing for me to do is to partition something into halves. So I always start when I'm making fourths with partitioning my model into half first. And even that's a little bit off. So I'm actually going to start over and do a little bit better. Need to bump that over here a little bit. That happens sometimes. Sometimes we just need to take a look at it. That looks pretty good to me. Right now it's halves. And if I start with halves, all that I do to create fourths is I partition each of those halves into halves as well. And now I have 4 pretty equal sized pieces. The same thing would happen over here. Start with halves, and then partition each half into halves. And now in each of my models, I have 4 equal parts. Pause your video again, and I also want you to label who's getting each of these parts from the context of the problem. So go ahead and label. You don't have to write their whole names. You could use an initial or an abbreviation to do so. So pause your video, label the parts in your tape diagrams, and then restart the video once you've done the labeling. All right, so you can see that while you were labeling, I was labeling as well. We've got 1 piece or 1 part going to Marcos, 1 piece to mom, 1 piece to dad, 1 piece to sis, 1 part to Marcos, 1 part to mom, 1 part to dad, 1 part to sis. Okay, or sister. I used abbreviations because it's just easier to use those abbreviations. All right, let's move on to the question. What fraction of the milk does each person get? So I'm thinking back to lesson 2, where we asked the question, or we had the sentence starter. There are blank equal parts in the whole. And that was a really important question to ask. So as I look at each of my holes, so I look at this hole, whether I drew it this way or this way, and my question in my mind should be, how many equal parts are in that hole? And I see 1, 2, 3, 4 equal parts. And if we have 4 equal parts in our whole, each part is called, if you're thinking either 1/4 or 1/4, that is correct. So each of these parts we could call, and I'm going to write it, and I want you to write it with me, 1/4, or we could also call it 1/4, because a quarter is 1/4 of a dollar. It takes 4 quarters to make a dollar, is one way to think about that. All right, so now we can answer our question. What fraction of the milk does each person get? So if you're using this application problem sheet like I am, down at the bottom, there's the lines to write your statement. Okay. If you're using blank paper, well, feel free to write it anywhere. Pause your video, write your statement, and then we'll go ahead and continue with our video and talk about that statement. All right, so here's the statement I wrote. Each person gets 1/4 or 1/4 of the milk. And we know that because the milk was partitioned into 4 equal parts. And when we partition something into 4 equal parts, we call each of those parts 1/4. So what I want you to take away from this and to utilize throughout the rest of this module is how important it is to think about how we're partitioning the whole and how we name each fractional part based off of how we've partitioned that whole. I'm Mr. Moses. Thanks for joining me. I'll see you again for lesson 4 application problem. Have a good one.
You've been watching MyIPS on MyINDY-TV 23, a free educational service provided by Circle City Broadcasting of Indianapolis. MyIPS airs weekday mornings from 8 a.m. to 10 a.m. For more information, special announcements, and the weekly program schedule, go to wishtv.com. You can also follow us on Facebook.